Hi, I'm Mark, and I'm going to show you a quick capacitance demo you could do with your students. So I have some 10 microfarad capacitors. They're very inexpensive. I paid 50 cents or so, probably less, at an electronic supply company for them. They are polar, so you may not want to let your students do this demo because they have a negative terminal and a positive terminal. If they're hooked up incorrectly, they could fail. This is an Lenco CM1555 capacitance meter. It only measures capacitance, nothing else. So it's a little more sensitive than the capacitance setting on a multimeter. It goes down to 200 picofarads. So I'm going to set it in the microfarads range. And let's connect one capacitor. We're going to build this network of capacitors. Before you connect the capacitor to the meter, you always want to discharge the capacitor. I believe it may damage the meter if you don't. So just touch the two wires together for a moment and I'll connect them. Since it's a 10 microfarad capacitor, we should see about 10 microfarads. Now the question you want to ask your students is, if I connect a second capacitor so that this network looks like this, two capacitors parallel to each other, what will the capacitance meter show? Ask them to make a prediction. And I'll find a second capacitor. The color coding the wires helps you to not make a mistake, obviously, in connecting the capacitors to the meter backwards. So I'll make sure that's discharged, and I'm just going to kind of crudely connect this in parallel, but it works. I'm going to put the blacks all together and the greens all together, clipped onto the respective terminals of the meter. So now I'm around 20. Well, students, what would you predict when I add this third capacitor? Discharge. And there's a third capacitor. We're around 30. I won't go all the way to 5. You get the idea. But let's look at series capacitors in just a moment. Okay, so now let's look at what happens when you connect these little 10 microfarad capacitors one after another in what we call a series relationship. So I've got my same meter and I've got a capacitor hooked up. Remember, negative to the black wire, and I've got the positive terminal of the capacitor to the green wire. I'm going to make sure it's discharged, and I'm going to connect it, and we should see about 10 microfarads on the meter. By the way, I mentioned that it's nice to have one of these dedicated capacitance meters because they're more sensitive than the others. They go to 200 picofarads. That's nice because sometimes you can measure things like a homemade Leyden jar, which is a primitive early form of the capacitor that students can make themselves. Okay, so I've got my one capacitor connected. I've got about 10 microfarads. So I'm going to discharge this capacitor. I'm going to disconnect the meter. I'm just going to be extra careful here. I'm going to discharge this capacitor. And then I'm going to connect black to green and black to black. Look at that. The reading is about 5 microfarads. What will happen if I connect a third capacitor? Well, let's disconnect. Let's discharge our capacitors. So there, that second one's discharged. And then I'll touch black to green of the first one, make sure it's discharged. And then I'll add my third. So we went 10 and 5. What do you think the third capacitor will be? What will be the reading when we add the third capacitor? Black to green. And here I go. Did you make your prediction? Go. About a third of 10 microfarads, which is the capacitance of the individual capacitors. What will happen if I add a fourth? Make your prediction. And I will discharge the capacitors. Here's another way to discharge them. Just take a loose wire, just touch it across them. I'll make sure that they're all discharged. And here's my fourth one. Okay, so now I'm going to connect the fourth capacitor. You must have made your prediction by now. Here's capacitor number 4. And we get about 2.5 microfarads. Now you can deduce how capacitors in series work. Thanks for watching. Remember, what one fool can understand, another can. So here's how I connect the capacitors in series and parallel. So when I'm connecting them in series, I'm just taking them. Here's one capacitor and connecting green to black, and then I'm making a loop with black to black and green to red. And then I'd add a third one and make a bigger loop, and a fourth one and a bigger loop. So that's how I was connecting them in series. When I'm connecting them in parallel, they go like this. I just discharged them, but double check. Take the black, put it on the black, take the green, put it on the red. Remember, I didn't have enough reds. And then to add another one in parallel, you're just going to put these right on top. So they're all clipped together in a big clump. That's parallel. There's a junction there and they're all together. And then if I were adding a third, I'd just add that right on top of there so that you get a big cluster of them. It's pretty quick and easy, and it's obvious that they're all joined together at that point. Thanks for watching. Remember, one fool can learn, another can.